Okay, we're going to look at basic integration now. So remember, integration, it's the opposite of differentiation. So integration and differentiation together are called calculus. So our general rule then, if dy by dx equals ax to the power of n, if we integrate that, then y would be ax to the power of n plus 1 divided by n plus 1 plus c, which is called your constant of integration. So our rule in words then, add 1 to the index and divide by the new index. Our first example then, integrate the following with respect to x. So this sign, it looks like a stretched out s, that's our integral sign, and we're integrating 7x to the power 4 plus 3x cubed minus 2x plus 7, and we'll have a dx here, and this is the with respect to x. So it's just saying we're integrating x's. So when we integrate, we add 1 to the index, divide by the new index, add 1 to the index, divide by the new index. Remember, 2 to the power 2x is 2x to the power of 1. So add 1 to the index, divide by the new index. And then 7 becomes 7x. And then we have a plus c. So remember, it's the opposite of differentiation. So if you differentiated this, you should get back to what's in the black here. So if you differentiate 7x, we get 7. So when we integrate a constant, we'll have to add in an x. Our plus c is because there could be a number. So if you had plus 10 here, when you differentiate, it would go to 0, so it would disappear. So we don't know if there's a number, so we'll have to have our plus c. And then just tidy up what you can. And that would be your final answer. So in the same way with differentiation, sometimes you have to change what we're integrating to make it possible. So if we were differentiating this, we'd bring the x cubed up, and it's the same thing with integration. So the 2 stays where it is, and it becomes half x to the power of minus 3. And that's what we're integrating. So add 1 to the index and you get minus 2. Just be careful with your minus signs. And then we're dividing by minus 2, and remember your plus c. Tidying that up, we get minus a quarter, x to the minus 2 plus c, or we could write that as minus 1 over 4x squared plus c by bringing your x to the power minus 2 down again. Part c then, we're integrating x plus 1 upon x minus 2. So we'll have to multiply out our brackets and then tidy up. And then we integrate. So add 1 to the index, divide by the new index. Add 1 to the index, divide by the new index. Our minus 2 will become minus 2x, and we have a plus c. Okay, now usually you will be integrating things with x, but you can integrate any letter. So notice now in this one here, we're integrating 4 over the root of y. So now we have a dy because we're integrating y's. So again, we know that root y equals y to the power of a half. So when I bring that up, that's going to become 4y to the power of minus a half. And that's what we're integrating. So add 1 to the index and then divide by the new index. And tidying that up, we'll get 8y to the half plus c. Or you could write it as 8 root y plus c. Okay, so in this one here with t's, and you can see we have dt because we're integrating t's. You have to divide it up into 1 over root t plus 3t squared over root t. So root t is the same as t to the power of a half. So when we bring up the first bit, it's going to be t to the power of minus a half. This part here then, that's 3t squared over t to the power of a half. So using your rules of indices, whenever we divide, we take it away. So 2 take away a half gives us 1.5. So that would be 3t to the power of 3 over 2. Okay, so we've tidied it up, so now we can integrate. Add 1 to the index, divide by the new index. Add 1 to the index, divide by the new index. Remember your plus c. And tidying that up, we'll get 2t to the power of a half plus 6 over 5 t to the power of 5 over 2 plus c. Okay, so we said at the start of this that integration is the opposite of differentiation. So when we differentiate a curve y equals something, we get dy by dx. So this is where we have dy by dx, and we're going to then integrate it to get y. So we've got dy by dx is 4x squared minus 2 over x squared. So to get y, we have to integrate this. So we're going to need to bring the x squared up and make it x to the minus 2. And that's what we're going to integrate. So add 1 to the index, divide by the new index, add 1 to the index, divide by the new index, remember your plus c, and then tidy it up. I'm going to bring that x to the minus 1 back down. And that's our general expression for y. Now it's called a general expression because we have that c there, our constant of integration. And we don't know what it is. So at this case, at this point, it's just a general expression. Our last one then, dy by dx is root x all cubed plus 1 over root x. So to get y, we'll have to integrate dy by dx. So x to the power of a half, which is root x cubed, using your rules of indices, would multiply the 3 and the half together. So we'll get x to the power of 3 over 2. And we'll bring the root x up. So it's x to the power of a half on the bottom. So when we bring it up, we'll get minus a half. So integrate that, add 1 to the index, divide by the new index. Add 1 to the index, divide by the new index. And then tidy it up. Now, in an exam, it's perfectly fine to miss out this line. Okay, I'm putting it in so you can see exactly what we're doing. But whenever you get good at these and you're flying through them, you can go straight from our top line here to our answer line here. Okay, you won't need that middle one with the kind of the messy bit before you tidy it up.